Good afternoon, everyone. My apologies for the little delay here, but it's pretty much a perfect example of why we always want to have redundancy in systems, because we had a wonderful Bluetooth device and it just decided to crash right before our presentation. So one of the things when we talk about AWS about high availability is redundancy, so that's what we try to put in place right now here. Now, apologies for coming in a little bit late. Today we're going to co-present here with Marco Lepistu, our Principal Technology Evangelist, Glenn Fields from PTC Thingmarks, and myself, Oliver Klein, to talk a little bit about robots and how we can connect, virtual with real worlds. And if we think about, robots, we think about automation, it's very much around how we can connect things together. This morning in the keynote, we saw, examples of how we use machine learning in our logistical warehouse, right? Things like that are generally driven by Kiva robots in Amazon warehouses. So today we want to have a little bit of a look how we can use some maker material to build small little robots ourselves and potentially then also use augmented reality. So what you can expect from this session is first and foremost, how can we use Bluetooth devices connected with AWS IoT, interconnected also with Lambda, so we put the glue in between the different systems that we have. We're going to leverage Amazon Alexa and create an Alexa skill to the skills kit to connect to these devices and then control it via it. We're going to use Amazon Lumberyard, Amazon's new game engine, and connect that game engine together with our robot via our AWS IoT service. And lastly, we will have a little peek into augmented reality. Now, to kick this off, we want to talk first about the physical world component. For this, I'm going to call Marco Lepistu on stage.
Thanks, Oli. Can you guys hear me? All right, good. So, first of all, welcome. Robotics. Originally, I was thinking of building a robot, but then I thought, no, it takes like 6 months for me to do that, so scratch that idea. Then I was thinking, I'm going to buy a drone and fly the drone with my code. But then I stopped myself right there. So if we fly a drone in this room with my code on it, somebody's going to get hurt, right? So let's not do that. So instead, I went to Toys R Us and I bought a Sphero. It's a really cute little robot, sits right here. It's actually pretty sophisticated. It's got a gyroscope, it's got accelerometers, all kind of sensors, and you can programmatically control it with Bluetooth. All right, Bluetooth. So I needed some IoT thing to let me control this bot with Bluetooth. So I went to my cupboards, I started rummaging, and I found this, an Intel Edison. Yes, I have a cupboard like that. Why did I choose the Edison? Well, pretty randomly, but it meets my requirements for this because it has Bluetooth, BLE, smart, the new Bluetooth, Wi-Fi, so it can talk to the cloud, and it's running full Linux, so I can install SDKs on it. So I did this. I installed the AWS IoT device SDK on the Edison, so I can talk to the cloud securely with keys and certificates, encryption. And I found an open source SDK called Cylon. If you're Battlestar Galactica fans, you know Cylons. And the Cylon SDK knows the Sphero, so it can talk the Bluetooth language of Sphero. So with those two SDKs, I can talk Bluetooth to the robot and MQTT up to AWS Cloud. So let's build this demo in stages and start with stage 1. Give me a second. Alrighty, here we are. So first of all, I have a little video camera here so we can see what's going on. Oli, if you can be my cameraman later. And this is the new console of AWS IoT. If you haven't seen it, about a week ago, it was refreshed and it looks like this now. So here I've got my things. For example, we've got the Edison thing here. What we want to do is log into it. So here, I have an SSH login to my Edison. And the first thing I'd like to do is to calibrate the orientation of my robot. So let's start a Bluetooth connection from the Edison to the robot. You can see that it woke up. It's got some lights on. And because it's a ball, I don't really know which way it's facing. So it's got a little blue light here in the back side. That's the bum of the robot. OK. So now we know it's facing that way. That way is forward. Fine. So next, what I'd like to do is to see if I can start driving the robot and if we can get some messages in the cloud. So what I'd like to do is to subscribe to an MQTT topic called Sphero. There's currently no messages there. But let's see, when we start driving the robot, if we start getting any messages. So let me now start the driving app on the Edison. So it's going to have two connections. Bluetooth connection to the robot, there we go, and AWS IoT MQTT connection to the cloud. And now we can see that when I started the driving app, well, first of all, the lights came on, and you can see that we got some messages. Action connect type Sphero. All right. So that seems to be working. We got some messages in the cloud, and if you take the camera, please. Let's see if we are able to drive the bot. And Oli is going to be your fancy cameraman here. So let me start driving and let's see what happens. There we go. All right, great success. So that's phase one. So we have Bluetooth control, the bot is moving, and interestingly, here in the cloud you can see that we get a copy of all the actions that the robot is doing, like drive in direction 0, which is forward at speed 70. Okay. Why is that cool? Why is that important to get the messages to the cloud? Well, let's see. Because we'd like to do something with the messages. Let's recap a little bit first. So we have a thing in the cloud. We have a thing configuration. How did I connect to the thing? Well, I load here the AWS IoT device SDK. That's the Node.js SDK running on Edison. And then here we use the Cylon SDK, Robot SDK, and we connect to my Bluetooth device, which is the robot. Then for AWS IoT, we need two connections. One is the MQTT topic connection, where we send and receive messages, the device, the thing. And then it has a shadow as well. And what we do is that when we connect to the robot, I want to publish a message, connect, and we saw the message coming. I publish it to the Sphero Actions MQTT topic. So that was working. Also, there's a reverse way. We want the cloud to be able to drive the robot. So if we receive a message from the cloud, we can parse it and then we can act on the message. So here's an example. If we get a driving message from the cloud to roll somewhere, we send a Bluetooth command to the robot with the speed and the direction that we receive from the message. We also connect to the shadow, and later we do something fun with the shadow related to the color of the robot. How did I actually drive the robot? Well, I was using the app on Edison. So locally pressing some keys, I'm reading the keystrokes, and for example, if I press the W key, that sends a Bluetooth command to the robot rolling forward at the current speed. And at the same time, we use the AWS IoT SDK to send a copy of the message to Sphero Actions. We are rolling at direction 0. And Space is stopping the robot, sending a stop message to the cloud. And finally, the robot is also able to give us events like collisions. It has sensors. So if the robot is publishing a message or sending an event collision, we detect it with the Cylon SDK. On event collision, what do? We publish a message up to the cloud, action collision. Why would we do that? Because let's give our robot a voice. It's really fun to drive it around here, but it doesn't say anything. It doesn't make any sound. Could we give the robot a personality? Let's try by adding a second IoT port to the equation, Raspberry Pi. Why did I choose the Raspberry Pi? Well, I had it, and it has a sound card. So I was thinking, okay, what if we could have the Raspberry Pi actually connect to the same MQTT topic, get a copy of the messages of the actions happening with the robot, then connect to the speaker system and play some sounds. For example, if we are rolling the robot in some direction, we send the roll message up to the cloud, Raspberry Pi subscribes to that topic, it gets a copy of the message, and then it plays a sound, go, go, go. Or if the robot is sending an event collision, that goes to the cloud, goes to Raspberry Pi, and it plays a sound, ouch. All right, let's see how that works. Switching back. Demo time. So now, we know the driving works. Let me disconnect the robot first. Start over. And before I start driving the robot again, here in the Raspberry Pi, I start an app a very simple app that uses the AWS IoT SDK, subscribes to those messages in that topic, that channel, and then plays sounds. Now let's see if that works. The Raspberry Pi seems to be connected to AWS IoT, and let's start driving again. Let's see what happens. Edison is connecting to the robot with Bluetooth.
Spiro connected.
Ah,
Hello.
she says hello. Sorry. All right, let's start driving.
Go, go, go. Go, go, go.
Let's change the speed, go slower.
Go, go, go. Ouch.
Yeah, let's go faster. How about in another language? If I press a key, I send a message from the Edison that changes the language to something else.
こんにちは。
Japanese.
行きましょう。痛い痛い。にーはお。
Chinese.
快樂快樂。
Hola. Ayo.
哎呦。你好。
Cantonese.
快啲啦。哎呦。
And the latest addition, Korean.
안녕하세요.
안녕하세요.
비켜 비켜.
Pikya pikya.
아이고. 아이고 아이고.
So the really cool thing is that the robot is fixed. We can't really change the robot, but because we connect it to the cloud, we can add functionality easily by just coding some simple stuff in the cloud. There we go. Let's put it back to English.
Hello. Spiro disconnected.
There we go. So now the robot has a personality and voice with the Raspberry Pi. But we are not done with the robot yet. Let's switch back to the slides. There we go. And next, really short recap. How did I do it on the Raspberry Pi? Simple app, device SDK and Node.js. We connect with the certificates and keys. I use the Raspbian Debian A-Play sound player that's part of Raspberry Pi operating system to play some sounds that we recorded, that you heard. If we connect to the Spiro messages, here we have some examples of messages, like if we get the collision message, we simply play the sound outs.wav, wave file. That's it. Here we have some examples of the JSON messages, connect Spiro, Lumberyard, driving messages, collision messages, and language change message. So really simple JSON messages. So that was part 2. We added a personality to the robot by adding it, giving it a voice. But what if we could talk to the robot? So back to Oli.
Thank you, Marco. Now you can see we're slowly starting to build and see the benefits of connecting devices together. And we want to add one more thing. You probably heard of the Alexa voice services and the Amazon Echo Dot device that probably pretty much every one of you earlier received as a little gift. Now, what can we do with the Alexa voice services? It allows us, obviously, to have our voice recognized, talk to the Alexa voice services in the cloud, but it also allows us to create an Alexa skill. And with an Alexa skill, we can connect it to a Lambda function. And in that Lambda function, we can write any kind of piece of code. So for example, we could use this to talk to AWS IoT and then potentially talk to our little robot up here. So what we're trying to do is, and Marco, if I can get you back on stage for the robot, what we're trying to do here is that we want to use the Amazon Alexa voice services to say, hey, Alexa, tell Spiro to change color to orange. And then what will happen is, obviously, that calls the Alexa voice services, which in effect will call an Alexa voice services skill. We created a Spiro skill here, which will call an AWS Lambda function, which goes to the AWS IoT platform and publishes a message to the topic. And specifically,
Spiro connected.
And specifically,
Hello.
Hello. And it's specifically, she's talkative, isn't she? Huh? And specifically, we're going to send. And we're going to send a message of what color we want to change the Spiro to, and in effect, then, the Spiro should then change its color. So how about we try this out? So let's have a little demo here, and I'm just going to switch back. Your PC. Yes, there you go. And I got a little Amazon Echo Dot up here, so let's see if that one's online. Alexa, say hello.
Hello.
Alexa, where are you?
I'm here and my head is in the cloud.
Good. Because when it's in the cloud, it can also connect to our Sphero. Now, Marco is recording the Sphero, so if we now want to call that skill, let's see if that works.
So currently it's green. Shadow is here.
And we see the shadow. There we go. Alexa, ask robot to change color to orange.
I changed robot's color for you.
And there we go. The color is orange. You can't really see it very well here with the
But you saw
iPhone.
the shadow change. So this is the shadow. It was updated online as Oli was talking to the lady in Alexa.
So let's try this again. Alexa, ask robot to change color to green.
I changed robot's color for you.
And there we go. We updated the IoT shadow value back to green. And the Sphero then changes color to green, given that the Intel Edison was listening on this topic, and sent a Bluetooth message to the Sphero and changed the color back to green. Now let's go back to the slides and try to understand a little bit better from a code point of view on how that would look like. And I keep hitting the wrong button here. Getting to it. There you go. There was a little sneak preview on what we're going to do next. So what are we doing here? Well, we created an AWS Lambda function. We created an Alexa skill with it. So we connected it to the Alexa skills kit by adding a trigger into the AWS Lambda function. We then went to the developer portal of Amazon and used the Alexa skills kit to create a Sphero skill. And then in that Lambda function, we basically then create the voice the voice output that we're going to send to the Amazon Echo Dot device, where obviously we want to say, I changed Sphero's color for you. And we also have another piece of code.
I'm not quite sure how to help you with that.
And yeah, we want to put her on mute, otherwise she's listening to me right now. We also put a piece of code in there that talks to the IoT service. And specifically what we use of the IoT service is the shadow state. So we change the shadow state of that Sphero robot, and in terms of the color, we change that shadow state from green to orange, or we change it back to green. So what you see here is basically a piece of code that would change the shadow state to change the color against the AWS IoT service. The AWS IoT service would then synchronize with the Intel Edison, and the Intel Edison would send that message back to the Sphero device. Now, how about we add one more component to it? Because, you probably got a bunch of developers here in the room, and, when I start to develop, I always love to kind of take things that I learned and just plug them together. Even though it might not always make sense, it's just cool to kind of connect things together, right? So how about we say whatever we built here with kind of a robot in the physical world, with IoT, where we connected devices together, Raspberry Pi and Intel Edison, how about we also connect that to a virtual world? And to do that, we're actually going to leverage Amazon Lumberyard. So Amazon Lumberyard is a free AAA grade game engine that is deeply integrated with AWS and Twitch. And we actually provide you the full source of Amazon Lumberyard. Now, the important part about Amazon Lumberyard is that it also has a component called Cloud Canvas. And that is that deep integration into AWS. With Cloud Canvas, you can build a game in Amazon Lumberyard, and that game can then be connected to different AWS resources, such as, for example, storage, database, compute, identity, queuing, and notification. And how do we do that? Well, basically in the Lumberyard engine, which, by the way, also comes with an IDE. In that IDE, we have a so-called flow graph. And the flow graph allows us to basically define nodes and then the logic behind what's happening in our game. And those nodes can be Cloud Canvas nodes. And that means that we can basically send an action that's happening within the game to a compute node in AWS, which would be an AWS Lambda function, for example. And then Lumberyard will handle the entire backend communication with AWS from you straight from the game. So let's first have a look into what Amazon Lumberyard is. All right. My mouse, there you go. Then you got to use that one. So what you see here is basically the IDE of Amazon Lumberyard. And I created a little level in here where you have a little hipster standing in front of an old school car with a bit of snow. And what you see, it's an IDE, so I can basically use my mouse here to navigate around and see what's going on. So we created a little level, and Amazon Lumberyard will take care of all the rendering. So we can put in objects, such as, for example, this little rock here. I could click it, and I could say, well, that's not big enough, so let's go ahead and scale this rock, for example. And then if I'm happy with my level, I can obviously go ahead and start playing a game. And here we see now, let me just restart this, take this robot bar away from you. We can now see the Amazon Lumberyard engine in effect. So we created a little robot here that I can now start navigating around. And you see the Amazon Lumberyard engine takes care of all the rendering of shadows and snow. We even have a little fire camp here. We have particle effects here, like this, the little fire and the smoke that comes out. Obviously, all the light is done and rendered from the Amazon Lumberyard engine. So we now have a small little virtual world that we have created here. And this little world, we can now give logic. How do we give this little world logic? Well, basically, we use something called the flow graph. So if I click on this little icon here, it will open up the flow graph editor. And the flow graph editor allows me to define certain logics within my game. So for example, if we look at this level down here, just navigate to that guy over here. So we created a little person in here. And you see that that person right now is actually kind of hovering around. Now that hovering around is actually an animation that we're playing through the flow graph. So if I look at that character in my flow graph, you'll see that the moment we start the game, we're actually going to start an animation, and that animation is, well, a relaxed kind of animation where he's drumming his leg. Now, at the same time, we can now draw other nodes inside here, and another node could be a cloud canvas node, which allows us to connect this game now to other AWS resources. In this scenario, I actually connected it to an SQS queue. Now, why do I do that? Well, because I thought, wouldn't it be cool if I could use my voice to actually interface with a character within the game? And if I say a certain something, I should allow my character to do a salute animation. Now, obviously, again, we use Alexa for that. And Alexa, again, we created a little skill inside the Alexa skills kit. And that skill will then send a message into the SQS queue and will help us to use our voice to actually connect this virtual world together and ask this guy to salute. So let's see if that works. Alexa, ask hipster to salute.
Hipster says hello.
There you go. All right, now we start to connect devices into the virtual world. So this is great. We can now use a device like our Amazon Echo Dot here in combination with our voice to actually connect it with our Amazon Lumberyard game engine. Now, let's try to have a look at what else we could do here. So the next thing that we want to do is, obviously we have a little robot in this game, and we now have a robot here on stage. How can we connect those both together? So the idea would be, can I take the robot in my Amazon Lumberyard level, and every movement that I make, can I send those messages to AWS IoT, which in effect then can send it to my Edison and my Sphero robot so that he drives and imitates the moves that I do within the game in the actual physical world here. Again, how do we do that? The glue would be Cloud Canvas within Lumberyard, so we saw how it worked with SQS, but we're now going to use the Cloud Canvas in combination with AWS Lambda. So whenever we make a move of the robot, we're going to call a Lambda function. Now, there's a little problem with that. Now, you'll find that the Sphero here actually drives with impulses. If you had a look at the messages earlier, you saw that there's a rotation coordinate that basically tells you from 0 to 360 degrees in what direction the robot will drive. And it will send another impulse, which basically tells with how much speed it should drive in that direction. Now, this is great for Sphero Robot. We can send a message and it will drive over there. In Amazon Lumberyard, though, we have a game engine that renders at easily 50 or 100 or more frames per second, and every frame per second could be a different interaction with your keyboard at a different position. which means we would have a very high frequency in kind of sending messages to the Sphero robot and move here, move a little bit here, move a little bit here, which obviously doesn't work very well and also wouldn't work when we combine that together with AWS Lambda and AWS IoT because we just send too much messages through. So how can we do it instead? Well, basically, let's think about how Amazon Lumberyard works. So Amazon Lumberyard, like most game engine, actually have X, Y, Z coordinates, right? So X, Y, and then Z up, right? How could we take those coordinates and then calculate a delta in a certain frequency? So instead of calling that lambda function for every different movement that we do, could we call it in a certain frequency, let's say, for example, 1 second, and then calculate the delta between this moment and the moment that we had 1 second ago? And that delta would then allow us to tell Sphero what the delta was so that Sphero can drive this. And obviously, we're going to publish that to the MQTT topic of AWS IoT so Sphero can drive that. Unfortunately, there's another little bit of a problem because XYZ is not really, kind of a degree and an impulse in a certain direction. So how are you going to do that? Well, I think that was probably the most difficult part of this presentation. I had to figure out the math how to do that. And actually, it's quite easy, because you go to high school and everybody could tell you that. Well, an impulse is pretty much a direction with a multiplication of the speed. So how do we get a direction? Well, let's assume we have an x, y, z coordinates. I'm going to drop the z now to make it easier. So we would have coordinates x and y at a certain point in time and a point in time later, which would be my 1 second snapshot later, x2, y2. We can obviously use trigonometry to then calculate that distance. Well, how does it work? It's basically like a triangle, and then we can use the tangent of the different deltas of those points to actually get the degree in which direction we are going. And similar, we can use the Pythagorean theorem with this nice little square root of the distance between the different points to actually calculate that distance. And well, we don't have the speed yet, but speed is pretty much distance over a period of time. We know the frequency which we're sending the lambda function through, which would be 1 second, so we can then calculate the speed that we actually have. And I'm going to leave Z out because Sphero, unfortunately, cannot jump yet. All right?
Working on it.
Working on it. So how does that work then in terms of connecting it back to AWS IoT? Well, Lumberyard will calculate those deltas, send it to a lambda function. That lambda function, in effect, will call then AWS IoT and send through the MQTT bridge that we established, it will send those commands to the Sphero. So let's have a look if I can get this going. So we want to connect our virtual robot, which you see here on the right side, which runs in Amazon Lumberyard. We want to take its coordinates of x, y, z, send it to a lambda function, calculate the impulses based on the delta of coordinates, send that to the AWS IoT, Intel Edison picks it up, and drives our robot. All right, lots of moving components. Let's try this out.
All right, let me reconnect to the robot first.
Sphero disconnected.
All right, connecting back.
Sphero connected.
Okay.
There we go.
Hello.
All right, so let's bring our little robot down here, and you can just be my cameraman for what? So I go back to my Lumberyard here, and here's the trickiest part to get that both on the screen. Let's resize that. And I'm working, by the way, on an Amazon workspace, graphics workspace here, because I don't have a strong enough GPU here to actually run my Lumberyard editor. There we go. And let me start the game again. Now, I can move around the robot, and you'll see that actually nothing quite happens yet. Now, the reason I did that is because I wanted to demonstrate you Lumberyard first without the robot driving. So we created a little MQTT message that I can send now from my game. If I hit a button here, that will connect Lumberyard to AWS IoT and, in effect, to the Sphero. Let's try this out.
Lumberyard connected.
Go, go, go!
There we go. OK, we connected our Lumberyard. And if I now start driving this robot, you will see that it will send those messages and drives the robot around in real life. So it sends it to the AWS Lambda function. It calculates the different impulse directions that we need to go through. and will then send that back to AWS IoT, publishes it to the MQTT topic, and I don't want to drive off the stage here, and sends that back to the Sphero. And if I'm done with it, I just disconnect it,
Lumberyard disconnected.
and I can drive again in the virtual world without actually having our robot drive in the actual world. So we had a little bit of fun with robots so far. Let's have a look at the final architecture of what we tried to compose here. We obviously tried to, thank you, Marku. We obviously tried to implement as many things as we could find in our office. And that's what we achieved here with a Sphero robot, an Intel Edison, a Raspberry Pi, etc. Connected that together. And the glue was pretty much AWS IoT to talk to the devices, and AWS Lambda to actually have the different services talk to each other, such as Amazon Lumberyard, and obviously our Alexa voice services with the Echo Dot device that we have here. Now, what we demonstrated here was a little bit of a few ideas on how you can use our services to obviously build and play around with little toys like this. But I also wanted to have a look into how could we do that in a more industrial manner, and how could we use augmented reality to make this all more interesting. And for that, I want to call Glenn Fields on stage, who's the VP of GTM and Strategy for PTC Thingmarks. Glenn?
Great, thank you. Am I on here? Okay. Yeah. That was awesome. That was really good, Oliver, Marku. So hopefully you all are enjoying reInvent and enjoying Las Vegas here. So I'd like to start off by talking about a theme we hear at reInvent, and that is change. And that could be the changing nature of products or the technology that go into products or how we interact with those products. So if you consider the world that we live in today, we have a physical world and a digital world, where the physical world has many physical objects that we interact with every day, and the digital world has lots of digital content that we rely on. We feel there's a convergence that's happening right now through the digital and the physical worlds combining through the power of the IoT. And that's going to create a lot of really great opportunities to create new amazing products or possibly reinvent existing products with a new form factor. One of the technologies that we feel will enable this is augmented reality. So by definition, augmented reality is the ability to superimpose digital content onto the physical world. So this is different than virtual reality, where you saw that you're totally immersed in a digital world. With augmented reality, you're fully aware of the physical world around you, and you can augment that with digital content. So what does that have to do with the Internet of Things? So I kind of have to define what I mean by the Internet of Things to gain an appreciation. So by definition, you have a thing that's sensorized, like that robot, that's pulling data off of that. You got to do something with that data and send it up to the human so that they can do something meaningful with that data. But the problem is, as we start to grow with more and more things out there, there's more and more data to interact with. And the question is, how does the human interact with all of that data? This is where we see augmented reality playing an important role through visual processing. If you consider all the data that's been created over the last 2 years, it accounts for 80% of the world's data. You look at over the course of the next 3 years, that's going to grow exponentially to 70 zettabytes. So augmented reality is really powerful in that it gives you the ability to visually process that information. I like to say our brains are visual processors, not word processors. And in fact, over 50% of your brain is set aside for visual processing. So if we can use big data analytics to crunch down some of that data and then use augmented reality to visually process that data through data visualization, we think that's a very powerful combination. So if you think about the Internet of Things and augmented reality coming together, that's really where our product, which is the Thingworks platform, will enable this technology. So I want to talk about 5 application areas of where augmented reality can actually assist there. Very powerful in the marketing and sales organization, where you can create digital representations of physical products where you might not be able to actually have those products. In the design stage, where you can actually use it to create and to iterate before you actually go to 3D print. To train in a safe environment, and to also operate and to service this equipment. So I put together a couple videos that illustrate this point. This particular one is showing a tabletop experience where you can do optical recognition to pull up some 3D content on what's called a tabletop. But the real power is when you can interact with this data with digital eyewear. So in this particular example, the lady is going to put on what's called a Hololens. Hopefully you've heard of the Hololens. And this is going to really unleash the power of augmented reality, taking it from a screen that might be your smartphone or a tablet and making you be able to see holograms in the real world. And you can also do really neat things by actually mapping the environment that you're in so that the HoloLens understands the environment. And then you can create real-life, full-size replicas of that digital content to interact with it, to show the features of it, to do design reviews of it, and you can actually change configurations. So in this particular example, it created a full-size live replica of this Caterpillar skidster. You can go in, actually see the clarity and the content of how it was actually built. So this is cool. This brings digital content into the real world, but what's even better is if you can take little pieces of that digital content and overlay it on the physical object itself. And then if we can actually take IoT sensor data and port that in through AWS, we can actually get a real-life understanding of how the machine's operating. So let me give you another example here. So again, we're using computer vision. In this case, a tablet. We can see that there's a problem. There's a high pressure alarm. This is an IoT sensor reading. We can put on a HoloLens, and now we can go in and actually interact with that live physical object to animate the digital content, overlay it onto the actual physical device to do such things as augmented work instructions for a service instruction. So Beforeiya is the technology that makes all that happen. You might not know who Beforeiya is. It's a company that PTC acquired about a year ago from Qualcomm, and they're really a leader in computer vision technology. So over the course of the last 4 years, they've done a really good job developing the ecosystem for augmented reality. We have over 270,000 developers developing technology with augmented reality, with over 300 million app installs on the Beforeiya SDK. So if you look at everything out there that's doing augmented reality, 80% of the applications use Beforeiya, which is great, but PTC wanted to take it one step further to connect the machine and the assets with this technology. So we created what's called Beforeiya, or Thingmarks Studio, actually. And what this is the content creation tool to be able to reuse existing assets. And what we do that's a little bit different is we use real live 3D CAD data of these physical objects. So pretty much every physical object that's made, before it's made with a computer model through a computer-aided design tool. So if we can take that file of the machine that it's actually built, pull that into our authoring environment, then we know exactly how the machine is architected. We know exactly how it goes together. We know exactly how it goes apart, so we could do sequences and animations. Now, if we could only connect to the IoT information and pull that in, we pretty much have all the information we would need to understand that machine in the digital and physical world. So there's one important piece of technology that I need to explain, and that is what's called a Thingmark. And the Thingmark is a unique identifier that launches the experience. So it contains all of the digital content or the sensor information for that specific machine that you want to pull down. It does something else too, and it contextually aligns the digital content with the machine. So since we're using real-life 3D content to actually build the experience, if we tell the software where this Thingmark is and we put the Thingmark exactly on the actual physical device, then the physical and the digital models will align. And that's what gives you the power to overlay the digital content in the physical world so it's actually blended. It's really hard to actually tell the difference between the digital content and the physical content. Towards the end of this presentation, I'll give you a live demo of a HoloLens where we actually put in digital content on a machine and we do an animation using the HoloLens, and it's very difficult to distinguish the two. The third thing is that it gives you the ability to scale. And this is what's really going to take augmented reality mainstream, is the ability to do this on a very wide scale. So the Thingmark allows you to be able to do something very specific to a specific piece of equipment and also to a class of equipment. So I'll use a vehicle, for example. So you could put one of these Thingmarks on your automobile and be able to pull up digital content, like say an operating manual for your Audi. But if you wanted to know something specific about your Audi, you could pull up a different experience that would pull up all of your maintenance history, when your next oil change is due. The sky's the limit there. So at a high level, the way it works is you create the content. So you pull in content that might already exist, whether it's 3D CAD content, PLM, SLM data, IoT sensor data, and then you publish that up to the AWS cloud where it's stored with a specific experience number and an instance number. And then you scan one of these Thingmarks. And if you have access control to be able to download this information, it'll download all of that digital content and also the sensorized content for that experience. And then you experience it either with your smartphone or your tablets or your digital eyewear. If we look at a little closer view of the architecture, you create your content on your laptop. When the content is done being created, the software automatically compresses all of the files, publishes it up to the AWS in the form of an experience where it's stored on what we call a Thingworks Experience Service. And this Thingworks Experience Service is coupled closely with the Thingworks Foundation, which pulls live sensor data through the AWS IoT connector that I'll explain here shortly. And it also pulls in back-end external data sources that you might have already created over the years for your specific piece of equipment. So when you scan this Thingmark here, it's going to pull up the digital content that you created and the live sensor data that's associated with that specific device. So why partner with AWS as an IoT cloud provider? It really solves two fundamental IoT business problems. That's the collect and connect and the interact. So AWS is very good at collecting data and connecting the data, storing the data in a very secure environment at scale at a very low cost. And what the Thingworks platform does is it allows you the ability to analyze that data, create experiences in the form of applications very rapidly, and experience it in a meaningful way through augmented reality. This is how the AWS connector works with the Thingworks platform. You have AWS connecting data on the edge. And what we're really interested in is we're interested in the deviations and the changes of that data as we're collecting it. And when there is deviations, it creates an IoT action that sends that data through the Amazon Kinesis stream in a Thing shadow format. And the Thingworks platform is monitoring this stream. So when there's a change, it'll automatically change it into the Thing model format, which puts it into the Thingworks core. And once it goes into the Thingworks core, that's what binds it to the actual physical object to be able to see live updates of that data on the machine itself. So it sounds like a lot of information. So I wanted to show you a real-life demo of how you would actually create an augmented reality experience. So going back 4 years ago, it might take 2 days to 2 weeks to create an augmented reality experience because you've got to graphically create the shell of what you want to see. Since we're reusing existing data, that might be 3D CAD data, it's as simple as going in, pulling in the file, putting it into your authoring environment, and publishing an experience. This is what's happening right now. So we've got our file. We went ahead and published it up to the cloud. We launch our single app, which is our View app. We look at our Thingmark, which I explained. Uses computer vision. Says, OK, I want to pull down this experience. You pick the experience that you want to pull. And then it loads that content into the real world. This is what we call a tabletop experience, which is 100% digital content. Now, if we just want to take a piece of that 3D model, we can do that. We can just take a piece and identify what it is that we want to take into our actual experience. We assign our sensorized data information, and then we can put that same Thingmark on an actual physical device, which we're doing here. So now you can see we're pulling in our live sensor data through AWS. And this right here is our digital content. You can see it's occluded behind the actual physical object because it's a 3D model. It knows exactly where it's supposed to be. And we can create a sequence to have it disassemble itself, come out from behind the physical object itself, and become a hologram to where you can actually interact with it. So this is done on the Hololens, so you can see my hand coming up and being right in front of the digital content. So very powerful when you're create new products to be able to converge this digital and physical world. So all this is real. It's out, available today. So we have a pilot program that I can make available to all you guys in the audience here. It's free. You can have access to a Thingworks Foundation and the authoring platform for Studio. This is the link. You go there, just sign up, and we can get you started creating content for the IoT. So thank you.
Thank you very much, Clem.
You bet.
Fantastic product. This is the end of the session for today. We wanted to demonstrate to you a little bit on how you can connect things and devices together, how we can use augmented reality, virtual reality with it. We're going to remain on stage here. I know we're in between you and the beer, but we're going to remain here for any questions that you might have. Thank you very much for your attention.